Namaskar students, this is Professor S. Lal, Professor of Mathematics and Computing, Department of Science and Technology, under the Faculty of Education and Methodology, Jayoti Vidyapeeth Women's University, VIDYAPEETH. Students, in today's session, we shall discuss about one of the best tools of probability that plays a very vital role in the solution of problems related to statistics and probability. That is Poisson's distribution. So please note down. Note down, please. The spelling of this is Poisson. Poisson. Poisson method in probability distribution. It is very much interesting and for the sake of convenience of this topic, I would like to share some facts on the screen. This is the Poisson's distribution, and you can go through this literature where the fact that why we have to study Poisson's distribution has been written, and in which cases an engineer is bound to apply, or an investigator is bound to apply Poisson's distribution. Many experimental situations occur in which we observe the counts of events within a set of parameters, like set, unit of time, area, volume, length, etc. For example, the number of cases of a disease in different towns as today COVID-19. The number of cases in different zones are different. The number of mutations in given region of chromosome, the number of dolphin pod sightings along a pipe path through a region, and so on. You can go through this. So how does this compare to histogram of counts for a process that is not write down? Histogram, you know, in your 10th and your 8th class, there was histogram. So these are the histograms. and you can see the distribution of different pipes in the different length of the histogram. Now, that process is just the pictorial representation of the fact. How a specific variable is to be determined, it is a matter of discussion here for us. And the Poisson's distribution, please see the statement of Poisson's distribution that is on your screen. The Poisson's distribution is a discrete probability distribution for the counts of events that occur randomly in a given interval of time. You should remember the statement of Poisson's distribution. This is very much important for your examination. Not only for university examination, but for your upcoming competitive examinations also. So I am repeating once. The Poisson's distribution is a discrete probability distribution. Discrete, not continuous. There are two types of distribution. You know well. Here we are talking about discrete probability distribution. I hope that you know the meaning of the discrete probability distribution. If you don't know, you should try to understand, and you can ask in case if you don't know, you can put your query in the inbox. Again, I will explain that. The Poisson's distribution is a discrete probability distribution for the counts of events. For the counts of events that occur randomly in a given interval of time. In a given interval of time. If we have a variable capital F and we are denoting that this is the number of events in a given interval, then the mean number of the event per interval is lambda, and there is a relation between lambda and x, means the probability of x at the point x is given by e to the power minus lambda, means exponential raised to the power minus lambda into lambda to the power x divided by factorial x. This is the formula. This is the Poisson's distribution, and we can apply this in getting the solution of our problem. One thing here is written that what is the value of a small e? You know well, is the exponential term, and its value lies between 2 and 3. But a small e lies between 2 and 3, and the approximate value of e is maybe equivalent to 2.7182. There should be a button on your calculator that calculates power of e. In case you are using mathematical calculator, in that case, you can find the value of e as we have written here. If the probability of capital X are distributed in this way, we write lambda is equivalent, probability not lambda. Lambda is a parameter of distribution. We say X follows a Poisson distribution with parameter lambda. Here are some examples, and you will be happy to see that how we can get the answer of our problem. Birth in a hospital occur randomly at an average rate of 1.4 birth per hour. Suppose there is a hospital, maternity hospital, where the average rate of birth is 1.8 per hour. What is the probability of observing 4 births in a given hour at the hospital? If someone is asking that you have to increase this rate, suppose the birth rate is 1.8, then you have to check that what is the probability of observing 4 births in a given hour at the hospital. For this, you have to apply this formula as we have written here. Here you have your lambda is 1.8 here, and this is here also. At x is equal to 4, as you want to determine the variable, we can put this value in this formula, the value of lambda and the value of x. Then we are finding this. Again, Ex is greater than equal to 4 is equal to 1 minus this. And this 1 minus this means what? We have to put the value of Poisson's distribution, like less than 3 value. That this is the result. So I hope we have got the details of Poisson's distribution. You should study this in case of any problem. You can mention in comment box. This session, this digital session 2.0 is powered by Jayoti VIDYAPEETH-PoissonTheorem University. I hope that you have enjoyed this session. In case of any query, you can write your comment in the comment box and I will resolve it. Thank you. Namaskar again.